Our lesson today, Unit 1, Lesson 6, is Applying Piecewise Functions. And I always like to talk about the vocab because to me that's just an important part of understanding math. So, we have a function. What is a function? Okay, the easiest way to determine whether or not you have a function is if you look at the graph, okay, and you can draw a vertical line. And I'm going to take that vertical line, usually do your pencil, and I can slide it, if it will let me, there we go, come on, slide it across my function, my graph, and as I'm sliding it across, you should notice that I never touch the graph more than one time. So if that is true, then we know that we have a function. Okay, so the next thing that we have is the fact that it is a piecewise function. Okay, and that word, this word wise, we use it a lot. Weather-wise, it looks like it's going to rain today, or different ways. It's just a word that we put onto other words to make it like an adjective. So, more importantly, a piecewise function is just many pieces of different functions. So, I hope you can look at this graph and tell me that there are 4 different pieces. So, this would be the first piece. This could be a second piece. This is a third piece, and let's go with the fourth piece. So I have 4 pieces to my function, and that function is describing Anne, who went on a 10-hour bicycle trip. The graph models the relationship between the time and the total distance. So notice that we have time down here, distance up here, and the table shows selected points on the graph. Okay, and again, we've talked about this in the past. Let's go with that. This, when you have D, you have T as time, and then distance as a function of time. So time is your independent variable, and the independent variable is the one that is graphed on that x-axis. Okay, so what we have to do in this first problem is we have to write a function d of t for her total distance traveled in miles in terms of the time t in hours. Okay, so to start off, piecewise functions always look like this. You have some function notation, and then you have this lovely brace that I know can be challenging for people to draw. Okay, but what you probably want to do when you're having to write a function from a graph is figure out how many different pieces you have. So I'm hoping you can all see that there are 4 pieces as we've highlighted. So that means that I'm going to have 4 pieces, and I'm going to run out of room, hopefully not, 4 pieces to my equation. So let's go write the first piece. Actually, before we write it, let's talk about this. We have, before this lesson, we've talked about we had a parent function quiz because you had to know what the general shape of something was when you looked at it. So hopefully you recognize this is a linear function, this is a linear function, this is a constant function, and this is a linear function. Okay, so we have 3 of them that are linear, and so I'm going to review what are the linear functions. What did our equations look like? And the one that we talked about most was y equals m times x minus h plus k. All right, and we knew that m was our slope, and our slope, of course, is rise over run. Now, the other one that you have that you're probably familiar with from Algebra 1 is y equals mx plus b. And what is b? B, of course, y'all know, is your y-intercept. Okay. HK, we talked about before, is any point on that line. So what makes this form easier to use is the fact that I don't know the y-intercept. If I didn't know the y-intercept and I had to use this form, then I would have a lot of calculations, and that makes a lot more work. And we're not really want to do that. So, first and foremost, we're looking at this first equation, this first piece of our graph that's highlighted in green. And ask yourself, do you know the y-intercept? Well, I do know the y-intercept. The y-intercept is right there at 0, 0. So this is going to be 0. So all I have to do is figure out what my slope is. Well, my slope is rise. How much do I go up? 3. How much do I go over? 1. So it's rise over 1, but we don't write it as 3 over 1. We simplify that to 3 and t, because we're writing it as a function of t, not a function of x. Now the other part that you need to remember about piecewise functions is you restrict what we call our domain. And we don't want this whole line y equals 3x. We only want the part that goes from here all the way to here. And so we do that by telling it which x values that we use. And that means, or excuse me, t values, because they're on the x-axis. So we have t being between 0 and 1. So that's the only part of that graph that we want. All right, let's look to the next piece. Let's go with that. Okay, our next piece, again, I'm asking myself, do I know the y-intercept? I do not know the y-intercept, so that means I'm going to use this equation. Okay, and again, I have to find my slope. So my slope is, to go from here, I go up 2 and over 3. I'm going to that point right there. So up 2 over 3. So my equation is going to be 2/3 t minus, okay, I need an hk now. What's an hk? I can either use this point here, which is 1, 3, or I can use this point here, which is 4, 5. It does not matter which one you use. We'll go ahead and use 1, 3. So t minus 1, comma, plus 3. Now, again, what are my t values between? Well, they're always going to start where you left off on the last one because they all connect. So that means that I'm going to go between 1 and all the way to 4. Okay, let's look at the next piece. Is it linear? It's not linear. It's a constant function. And what is the constant value that it is? Well, the constant value that is 5. So we're just going to write 5 if t is between what numbers? Again, we always pick up where we left off. And so how far does it go? It goes from 4 all the way to 7, it looks like. And then now we have the last piece. And our last piece, it is linear. We do not know the y-intercept. So again, we're going to use this equation. And I have to go calculate my slope. And my slope is up 5 over 3. So up 5 over 3. That is my slope, 5 over 3. And t minus, pick any point you want. I'm going to go ahead and pick this one, which is 10, 10. And that's t minus 10 for your x coordinate. And then plus 10. And again, if t is between, we always start where we left off. And then we end, you can see that we're going between 7 and then we end at 10. So that's our function. And I'm sure y'all seen those, but I hope that makes you realize that those aren't as scary as they look, because they look a little bit complicated, but not so bad. All right, so now they are asking us to evaluate d of 3. Okay, so d of 3, this is, the 3 represents the t. So you're looking on your graph and you're saying, okay, when t is 3, okay, this part right here, what is my graph, the value of my graph? Well, I don't know what that number is. Okay, it's a decimal. Okay, but regardless if it's a decimal or not, you need to support it algebraically. So we got to figure out which of these equations I'm going to plug it into. You got 2 ways to look at it. You can either go look at your graph and say, well, it's in the second piece, so I'm going to use the second piece. Or if this is your t value, 3 is between 1 and 4. So t is between 1 and 4, then I'm going to use this piece. So we're going to go plug in, and that's 2/3, 3 minus 1 plus 3. So when you plug that in, that gives you a value of 13 over 3. So it tells us to write an ordered pair. What's on the inside is the independent variable. That comes first. So it's 3 comma 13 thirds. That's my ordered pair. Now, explain it in the meaning of the context of the problem. Okay, 3 is the first one, which represents our time. So we say after 3 hours and has traveled. And we don't usually write 13 thirds, so I'll go ahead and put that as a decimal. 4.3 miles. I just rounded it to the tenths. And that would be our answer. That's all we need to do. Okay, the next part. Draw a graph of Anne's speed in miles per hour in terms of the time in hours. Okay, so we're doing another graph. And this time, okay, we have speed versus time. And yes, time will continue to be on the x-axis. So speed is over here. Speed is in terms of miles per hour. Time is in terms of hours. And as I've mentioned before, if your grid is by ones, you don't have to label it for me, but I'm just going to do it to help this demonstration. 2, 4, 6. Oh, go away. He's not going to let me go away. There we go. 6. Come on. And gotta love technology. 6, 8, 10. And it'll work this time. 2, 4, 6, 8. Okay, so we're looking for the speed. Okay, so we have 4 different pieces, and in this first piece, between 0 and 1, okay, she went 3 miles in 1 hour. So I hope you know that means that her speed was 3 miles an hour. So when we do this, let's start back here. Okay, this speed graph, we're going to have all open circles on it. Okay, so it was between 0 and 1, and her speed, that doesn't look like an open circle. Let me make it a little bigger. Okay, nope. Oh my stars, what did I do? Let's try that again. Pause. Okay, I didn't want to make you suffer through my figuring out technology there. So, what I did, open circle at 0, open circle at 1, my speed was 3 miles per hour. Okay, on to the next piece. The next piece, okay, right here, she traveled 2 miles in 3 hours. Well, if it's 2 miles in 3 hours, then it means that that's 2/3 of a mile in 1 hour. So, go back to my, yeah, we're there. Boop, boop. All right, 2/3 of a mile. So where is 2/3 on here? It's just below 1. So I'm going to draw an open circle at 2/3. And how long did she do that? It was 2 miles over 3 hours. So 1, 2, 3 hours. And that was from 1 to 4, like we said. All right, and now I'm going to connect it because her, her speed didn't change during that time. So I'm just going to connect those two. All right, next we have the next piece, which is constant. So what is her speed? If it's constant and she's not going anywhere, then I hope you all are jumping and saying that means that her speed is 0 because she didn't go anywhere. So 0, and she did that for 3 hours all the way to 7. And let's go connect that. A little bit hard to see, but I think y'all got it. And then the last one, from 7 to 10, this one, what is her speed? 5 miles in 3 hours makes her speed 5/3 of a mile per hour. So 5/3 is 1 2/3. So I have it here and here. And we will connect that. Oh, right there with that one. With another horizontal line. So that is our speed graph. Now, the next question says, what is the relationship between the speed and the equations for d of t? So what you're supposed to be doing is looking at the speed each time. This is a speed of 3, a speed of 2/3, a speed of 5/3. And when you go back to the equations, what do you notice? We had a speed of 3, a speed of 2/3, and a speed of 5/3. So my students didn't have any trouble figuring out that the speed, well, that was not what was supposed to happen. Oh, I'm in the wrong thing. The speed is the same as the slope for each corresponding piece of the function. Okay, last but not least, they want us to write an equation, write a function s of t for her speed in terms of t. So just like we've been doing, okay, when you look at my graph, you look at our speed graph, we have 4 pieces. So it's that same thing we've been doing, okay? I'm going to have s of t equal, I'm going to draw my brace. I have 4 pieces, so I'm going to draw 4 lines so that I remember, oh, well, that wouldn't look good. I can remember that I need to have an equation for each piece, or a description for each piece. So looking at the first one, we have, what is the speed? Okay. More importantly, before we even get there, what are these? Are these linear? No, they're not. They're constant functions. So if they're constant functions, we know that that the equation is just y equals a number like we had up at the top. So what is that number right there? It's 3. And that is if t is between 0 and 1. And then the second one we have, it was 2/3 if t was between 1 and 4. And then the next piece, we have a speed of 0 because we didn't go anywhere. And that is between 4 and 7. And then the last piece, the speed was 5/3. And that was between 7 and 10. Okay, so what's going to happen? The back side of this sheet, you have another problem very similar, but you're going to start off with a speed graph, and you're going to work your way back to a function, a graph that's going to describe the distance in terms of time. So I hope that helps that process and helps you get that done. If you have any questions, please come see me or feel free to email me. Thank you very much.